Welcome back, everybody. We are going to talk about Unit 4, Day 2, which is going to be talking more specifically about graphing sine and cosine when the equations are a little bit more complicated than just shifting up and down and doing a vertical stretch. So the more complicated equations take the basic form of y equals a sine, and then in parentheses, bx minus c plus d, or if it's cosine, it looks the exact same, but with the word cosine. All right, and then each of the letters in these equations stand for something special. So if you have a in front, so a here, or a here, then a represents amplitude. So amplitude is the displacement from the midline. And the way you find that is you take the absolute value of whatever a is. So if there's a negative in front, the displacement is just going to be a positive, because displacement is always going to be positive. Okay, so that's why we put it in absolute value bars. Period is going to be the length of one full cycle. And we did talk about this last year in Math 3. We did a whole little investigation on it. The period for the mother functions of sine and cosine is 2 pi, or 360, because that's one full trip around the unit circle. But if you are changing how fast you go, that changes things a bit. So period can change. And what changes that really is this number in front of x. So this value here, b, will change that. So what you do is you say 2 pi divided by b. Or if you're doing this in degrees, it's going to be 360 degrees divided by b. All right, phase shift is shifting the graph left or right. So this is a left-right shift. Okay, and that is going to be found by doing the opposite of C divided by B. Always do opposite of C divided by B. Now mathematically we write that as doing negative C divided by B. Okay, so this one you're going to use this number here. Okay, and then the last one is a vertical shift. That one you should be fairly familiar with. The vertical shift is going to be found using the last number, that is this one right here. That tells you how far up or down you're going to shift your midline. So this is an up-down shift. This is where you put your midline. Okay, so you can use all that information to find amplitude, period, phase shift, and vertical shift for each function. So in this first one, amplitude, you're going to use the A in front. This is an understood -1, so amplitude is absolute value of -1. That's just 1. Period, you are going to use the B value. So it's really helpful if you rewrite this as -1 cosine 1/2 x, so the b value is 1/2. So period is going to be 2 pi divided by 1/2. If you keep change flip, that becomes 4 pi. Phase shift is opposite of c over b. There is no c value here because there's nothing out here. So phase shift is going to be 0. You're not adding or subtracting anything with x. Vertical shift, again, we're not adding or subtracting anything on the end, so there is no vertical shift. For number 2, amplitude is this number out in front. Absolute value of that is 1/2. Period is 2 pi divided by the number in front. So 2 pi divided by 2. That's just pi. Phase shift, we are going to do opposite of c divided by b. So we are going to do opposite of -1, which is 1, divided by b, which is 2. That's just 1/2. Vertical shift is this number out here at the end. That's 3. So we are just going to have a phase shift of up 3. And number 3, amplitude is absolute value of -3. That's just 3. Period is 2 pi divided by the number in front of x, which is this. So 2 pi divided by pi, if you simplify that, you get 2. Phase shift is opposite of c divided by b. So opposite of -2 is 2, divided by b is pi. So your phase shift is 2 over pi. And then vertical shift, there is nothing added on the end here. That's like saying +0. So you've shifted up and down, nothing. All right, these graphs down here, I recognize that the numbering is out of order. That is fine. Amplitude. We said at the top, amplitude is your displacement from the midline. So the first thing you need to do is recognize that the midline is the horizontal line that cuts your graph in half. That's this guy right here. It's where you have half of your hills above the line and half of your hills below. So here and here. Okay, your amplitude is how far you go away from the midline in either direction. So this hill goes 3 units above. The bottom one, the valley here, goes 3 units below. So your displacement from the midline is 3 units. So that's your amplitude. Period is how long it takes you to complete one wave. So one wave, you can start anywhere you want. I'm just starting at the origin. One wave is 1 full cycle. Okay, so I just started at the origin and ended. This graph is not really labeled very well. If 2 pi is right here, that means this pi, this should be labeled right here. So 1 full wave is right here. So I go from 0 to pi to complete 1 full wave, so the period is pi. In number 11, the amplitude, again, is the displacement from the midline. The midline is right here. Total displacement from the midline, if I go from the midline to the very top of a wave, that's 4 units. So amplitude is 4. The period, I need to complete 1 full wave. Again, it doesn't really matter where you start. I always find it easiest to start at the y-axis and then complete 1 full cycle. So for this one, I'm going to start where I'm crossing the y-axis. That's at the top of a hill. So I want to go 1 full cycle. That means I want to go back to where I'm coming to the top of a hill. So that would be 1 full cycle. So that would be to 2 pi. So the period is 2 pi. So in this one, I would consider that a cosine wave. Number 12, amplitude is going to be displacement from the midline. Here's the midline. cutting your graph in half. Displacement from the midline is 2 units. And then 1 full wave is going to go, if I start at the y-axis, go up a hill, down a hill, back. That would be a sine wave, if you see that. It goes to 4 pi, so the period here is 4 pi. All right, we are going to write the cosine function as a phase shift of the sine function. So in looking at that, okay, they basically want us to say this cosine graph starts right here. I want to write that as a sine equation. So if you trace this a little bit further, if I start it right here, and stop my tracing right there, if you see what I've traced in pink, that looks more like a sine wave, starting at the midline and ending back at the midline. That looks like a sine wave. So they want to write the cosine graph as a phase shift of the sine graph. All right, so I'm going to write y equals, and so if I've traced that and it looks like a sine wave, normally sine starts where the yellow graph is. All right, right here, what I'm tracing now, that's a sine wave, okay? But what I traced in pink, in solid pink, is that yellow graph shifted to the left pi over 2. So if I want to write the cosine graph, the blue one, as the yellow one shifted to the left pi over 2, that equation would be sine x shifted to the left. Remember, shifting left is opposite of what you think, so I'm going to say plus pi over 2. Now that would be the same exact thing as writing cosine of x. And if you doubt that, you can pause and graph this in your calculator, y1, and this one in y2, and see if you get the same graph. But if you're going to do that, make sure your calculator is in radian mode. All right, we are going to graph some graphs by hand and see if we can graph these more complicated graphs that we're not just shifting up and down and doing a vertical stretch on. So to graph them by hand, you're going to determine the vertical shift. That's where your midline is. Then we're going to determine the phase shift. So between the phase shift and the midline, that's going to help you determine where your wave starts. You're going to determine amplitude to tell you your displacement from the midline. And then you're going to determine period, because that's going to tell you where to make your wave end. Because that tells you how, like, the length of one wave. All right, so those are basically your steps. So we're going to go through that on these practice problems here. All right, it says find amplitude, period, phase shift, and vertical shift, because you need all 4 of these things in order to graph. And then we're going to sketch using radians. Your graphs here are already pre-marked for you to help you graph. Now the very first thing I noticed in number 2 is that they put the vertical shift at the beginning, and I don't like that. So I'm going to cross that out, and I'm going to put -1 here at the end, just because I feel more comfortable that way. So I'm putting that at the end. All right, so amplitude in this one, amplitude is 4. The period is 2 pi divided by the number in front of x. And some of you are saying, that's not an x, that's a theta, and that's weird. That's okay. If you want to change that to an x to make you feel warm and fuzzy inside, you can. Theta and x, they both stand for unknown angle. That's fine. So period is 2 pi divided by 2, or just pi. So one full wave gets completed between 0 and pi. That's what that means. Let's see, vertical shift. Oh wait, yeah, phase shift, sorry, phase shift. Phase shift is opposite of C over B. There is no C in this one, so there's no phase shift. Vertical shift is down 1. All right, so the very first thing it says to do in our steps is to determine the vertical shift, because that's where the midline of our graph is going to be. So our midline is going to be at -1. So I put kind of a dotted line here. That's our midline. And again, that is not an asymptote. I just put that as a reference. So you can kind of pretend that that's your x-axis. So our wave is going to be centered around that line. Next, your phase shift, it's 0. So that means our wave is going to start on the y-axis because we are not shifting left or right anything. So the beginning of our wave is on the y-axis. Determine our amplitude. Our amplitude is 4. This is a cosine graph. Cosine waves start on the y-axis at the top of the wave. The top of the wave is going to be 4 units from the midline. So from the midline, we're going to go up 1, 2, 3, 4. That's up here. It's going to end pi units away from that. So pi units away is here. So I need to complete one full cosine wave. So it's going to go down and back up. Okay? So that's the general shape of a cosine wave. Now what I drew is not the actual wave. I'm just giving you the idea. Halfway in between these 2 points I've already plotted, halfway in between it needs to be 4 units below the midline. So halfway in between is pi over 2. I'm going to go 1, 2, 3, 4 units below. Halfway in between those two is where it's going to hit the midline. And halfway in between hits the midline again. Everything's pretty symmetrical. So here's one cosine wave. And do the same thing on the other side of the y-axis. Pi units, it's going to be at the top of the wave, halfway in between, bottom of the wave. Halfway in between hits the midline. Okay, and there's another cosine wave. All right, so there you have it. All right, number 3. Number 3, we're going to graph this one. Amplitude is 1/2. Period is 2 pi divided by 2. So pi again. Phase shift is going to be opposite of C over B. So negative pi over 2 divided by 2. That's going to be negative pi over 4. And then vertical shift is up 2. So our midline is up here at 2. Phase shift is left pi over 4. So left pi over 4 is right here. So I'm going to put a vertical line right here. So both of the dotted lines are like our new axes. So we have a new y-axis and a new x-axis. That's going to be our reference points for where we're going to start graphing. Okay, this is a sine wave. Sine waves usually start at the origin. So our new origin is right here. So we're going to start graphing at that new spot. Okay, our period is pi. So pi units, if you look at the original graph, pi goes 1, 2, 3, 4 blocks. So from the point that I first plotted, I'm going to go 1, 2, 3, 4 blocks. So that's how long one wave needs to be. Okay? So I need to make a sine wave there. On the mother function for sine, it crosses the midline halfway in between. So I need a point right here. Halfway in between that is where it's at the top of its hill. The top of its hill has to be half of a unit away from the midline because the amplitude's a half. And halfway in between here is going to go below the midline. So there's your sine wave. Do the same thing on the other side, except for sine, it's inverted. So it looks like that. Okay, number 4. Again, this +2 I don't like. I'm going to put it at the end. Your amplitude is 3. Your period is 2 pi divided by b. Again, if you want to make this an x, you can. So this is a 1/3 for the period, so that makes this 6 pi. Your phase shift is going to be opposite of c, so -2 pi over 3, divided by b, which is 1/3. Keep, change, flip, you get -2 pi over 3 times 3 over 1. That's -2 pi. Your vertical shift is 2. So you're going to start this at 2. Your phase shift is -2 pi. And this is a sine wave. So again, we're going to start this at the new origin, which is where these two dotted lines intersect. The period is 6 pi, so we need to go 6 pi units. If you look at your graph, 1 pi is 1 block. So we're going to go 1, 2, 3, 4, 5, 6 pi, and that's where we end. Halfway in between is where this needs to cross the midline again. Halfway in between two of these points is where the top of the hill is going to be. And according to our work here, top of the hill's got to be 3 units away. So halfway in between, 1, 2, 3. Halfway in between 2 points is where the bottom of the valley is going to be. So there's your sine wave. There you have it. So that's what it looks like. All right, the last thing on here is modeling. For modeling, you need to get a calculator and you need to type this information in. So you're going to type all of this into your calculator, and you are going to go to Stat, Edit to do that. And once you type that all in, you're going to go to Stat, Calc, and guess what, y'all? There's a sine reg option. So you're going to choose that. And as our video is running a little long, I'm not going to go through that with you because it'll take me a while to type all those in. And I don't know how to do what Miss Marshall did when she just made the answers show up. So I will go over those with you in class. But you're going to do the same thing in number 2. You're going to go to Stat, Edit. Enter this stuff in L1, this stuff in L2. And then you're going to go to Stat, Calc, and go to Sine Reg for the sine regression. And it will give you the equation. And you're going to use the equation for this one. You're going to use the equation to find the depths at 9 a.m. and 3 p.m. So you can actually answer some questions about different data sets. And that's what we're going to do in class next time. And it's going to be amazing. I hope you've enjoyed this video and you're prepared to do our activity next class, because it will be a graded activity and you're going to have so much fun. Till next time, Toodles.